Wait, can you go over 5? You just statemented me wrong, so I got no idea.
Blanket statement. I blanket statemented you.
You did.
I did a weird verbing of a noun to you. Okay. I like verbing nouns. What? There. What's this?
Add 1 and 2, not multiply.
Okay. All right, guys. This problem. Oh shit! How can I show it without? Yeah. Okay, I can do this. Wait, it's not this one. It is.
Better than. But yeah, they don't.
There's this one. That one, right?
Yes.
Okay. I'll have another copy. That's not to use somebody's paper. Don't worry about it. One part of this problem was actually you have to be able to read your students' work. And you'll start to understand, for a math teacher, it is so frustrating when people do everything in the same line. It's so much better if you do it this way, because then it can follow what goes to what. So a lot of you guys thought that was its own problem, which is not true. That's the problem. Their first step was to do this. Yes?
Yeah.
That's the problem they were given. Their first step was to do it. So what did they do?
Oh.
They made it like the bottoms were right, but then.
Well, no. That's the first mistake. When you multiply things, do you need LCD? Nope, hell no. In fact, that's the opposite. We normally try to reduce things. We don't want to build them up. We want to reduce them. So the first mistake they made was they thought they needed an LCD and they don't. Now, it's still salvageable because this is still true. This is a true statement. That first thing is a true statement. It's just they didn't need an LCD. You with me? So the first place where they came out to be completely wrong was here. And I think most of you guys got that. The 3 times 4 is 12, but 6 times 6 is not 6. It's neat.
Oh, so I just explained. I read it wrong, so I explained it wrong.
Oh, I see. Yes,
I thought it
exactly. A
was
few
the-
people did the same thing. But again, it's interesting because I want to have a few problems where I grade you on your ability to be a teacher. And I know you're not a teacher yet, but you need to be able to tell. That's the problem that was given. That's the first step they did. That's the next step. Now you're gonna, when you're teaching math in your job, you're gonna say, please, dear God, students, please don't put all your work in a row like this. Because that is really hard to follow.
Rows bad, columns good.
Columns good. You guys with me on that?
Okay, so.
By the way, was the other problem, yeah, there was the problem before this was the one about division mixing smaller. Okay,
Yeah.
if you combine that, multiplication only makes things bigger. But multiplying by a number less than 1 makes it smaller, correct? So another way to look at this is, if I do 1/2 times 2/3, the answer should be smaller than either one of these. But you got 2, so that's like a first level.
Yeah.
How do you check? How do you know you made a mistake, right? And when you're doing mathematics, that as a teacher, it's a really good thing. You want to give your students an ability to make sure their work makes sense on some level. So for me, it's like, don't tell me the shed's got to be -5 feet by whatever, Okay, something went wrong. Don't just circle that shed. Because I'm like, I don't want to go into your shed. Is it a black hole? What is that?
I don't know. The baseball traveling is 4 times the speed of light. Makes
Yeah.
pretty much good
Yeah.
sense.
Yeah. That guy ain't gonna catch it. He's gonna die. Okay. Anything else, guys, before we move on? So just to remind you, when you make corrections, you can say, Jeff, I'm not turning these in. Can you tell me if they look good? And then I'll tell you the ones that look good, and I say the ones that don't look so good. And then if I have time, I could even help you. So, dear God, get help. Get as many points back as you can for corrections. Yeah.
You said get help.
Yes.
Compression.
Yes.
Yeah. I think last time I passed it over.
So we're not going to do them right now. I need to get into the new stuff, but like during office hours or whatever, I could help you. That's one thing I can help you with is corrections. And somebody's face lit up, just make sure. Anything you haven't corrected yet. So the order operations for going forward should be new homework number 1. Test corrections number 2, because they have the biggest effect on your grade. Quiz corrections number 3, right? And then old homework stuff number 4.
What if it's a missing?
Old homework stuff number 4.
Yeah.
Yeah. I think I haven't told you guys this yet, but homework is worth 5% of your grade. I don't say that directly in the syllabus. I kind of hide it. I put it together with quizzes. Yes.
The main thing is, as long as you know what you're trying to get taught.
Yeah. So you guys can see that homework will affect your grade. You can see that,
Yeah, not very much.
Not that much.
but not like a ton. Because
Like 1%.
to me, in a perfect world, homework would be worth 0. Because if you do it, it helps you, and if you don't, it hurts you. So you're already getting screwed if you don't do it. So to my mind, it sucks to screw you again, right? You're already screwing yourself. Does that make sense so far?
I didn't teach you that homework is worth 60%.
Yeah. Then I got my colleagues who make homework worth like 40%, and they don't even look at it. So they get an A, and then they can fail every test, but they pass the class, and then they take me, and then I'm an asshole, right? Anyway, enough of that. So let's get into new stuff. If there's no other questions. Oh, not sure everybody. Test. Yeah, okay. So what we're about to get into, let me ask you guys a couple of like feeling out how much you are aware of these ideas. Ratio and proportion. Ratio. Ratio. What's a ratio?
Yes.
Oh, a ratio.
Aren't fractions technically ratios?
Fractions are technically ratios, exactly. We call them rational numbers. But these are a more of a generalization on top of fractions. Yeah.
How much you have of one thing compared to another, like
Yes.
1 apple to 4 strawberries.
Yes, beautiful. So a natural place we see ratios are like recipes. 3 eggs to 2 cups of milk or whatever. Yes? You guys kind of with me? If you've ever baked anything
So like if you have more.
and you had to adjust it to make for more people, you know ratios. Or you've worked with them.
Half an egg.
Oh my goodness, purple is aggressive.
Purple's a good color.
That one does this.
That's my daughter's favorite color, purple.
Doesn't help that the eraser's old as hell. What will do you better? You are
Ratio,
solid.
isn't it?
I don't know why they make this ratio.
Is the ratio somebody in Roman, Junior?
I think that would ruin the board.
You ever seen the Jake?
What?
I've used this for multiple networks. Just use
Oh.
But then you use purple after you just use it.
I have spray I'm gonna use in a minute, but I don't wanna use it after every time I write. So a ratio, for example, if there were 4 cats and 7 dogs, I can make a ratio of cats to dogs. And there's several different ways I can write this ratio. I could write it like a fraction, or I can write it in this format, which is really relegated to ratios. Has anyone ever seen that way before?
Yes.
Yeah. If you ever go, I don't want to do this, but if you ever go to the horse races and you're betting on horses, you're okay. It's so cruel for those horses, but
It's gambling.
yeah, it's game. Anyway, you'll see the odds. Odds are another form of ratios. Don't know what generally the odds do. So 4 to 7 or 4 to 7. So this is called part to part. This is part to part. Because how many total animals are there?
7.
No.
Four.
No.
How many total animals? 11.
Oh,
4 cats, 7 dogs,
Oh.
right? So there's 11 total animals. Does that number show up in either of those representation, no. So I could do, of course, the other way I could do is 7 to 4. So I could do dogs to cats. So that's another part to part. Or I could do 4 cats to 11 animals. Let me just put the units on there. Right, 4 cats to 11 animals, 4 to 11. Or I could do, and then of course I could do 7 dogs to 11. Or I could do, so this would be what's called part to whole. The names are kind of silly,
That makes sense.
right? So if I put a part over a whole, that's a part to whole, it's amazing. So if the total number shows up, it's going to be some kind of a whole. And of course I could do 11 to 4, which you don't see very often. Jeff, you can do it, buddy. Animals to cats in this case, 11 to 4. Plus you would never guess this, but this is called whole to part. Sorry, I was being facetious. Okay, nothing too amazing there. So, for example, so ratios themselves are pretty straightforward. There's not much to them, and they can look like fractions, but do you see how they're not the same thing as fractions? Fractions always involve the total on the bottom, correct? Like 4 out of something. Ratios don't have to. This being more than 1 doesn't necessarily mean the same thing as a fraction being more than 1. Okay, maybe. Could you have, could the second number be 0?
Yeah.
Yeah, so in a fraction, can this be okay in a fraction? No. If this is a ratio of cats to dogs, what would it mean?
You have 7 cats to 0 dogs.
Yeah, 7 cats, no dogs. So technically, you could have a 0 show up in the bottom of a ratio. Okay. Oh, I got it. So if I have a problem like this, let's say I have a recipe. Okay, that's a little better. A little bit better. There. And it takes, let me see. I wrote a little recipe down. I made this up. Let's see. I'm not even sure this will make anything good. So let's say I have a recipe and it calls for 2 cups of some kind of mix. So I'm just kind of taking the cheap way out. 1 cup of milk, 4 egg whites, 4 teaspoons of oil. Okay, that's enough, Chef. And this all makes 8 servings, whatever this thing is. Bagels? Muffins?
I wish bagel for this.
Lemon bars? Pancakes? Sure. Banana bread? Baby banana bread? Okay. Whatever you would like to imagine, that's what it could be. What if I've got, what'd you say, Jeff? Yeah, nothing too weird. Yeah, what if I got 10 people coming over, so I want 10 servings?
You make 16. People get plenty.
How many egg whites would I need? So what is the current ratio of egg whites to servings?
4 to 8.
Yeah, 4 egg whites to 8 servings. Is that cool?
Yeah.
So I need to make 2 ratios now. And of course the idea is the recipe, the way recipes work is the ratios have to be constant. So if I want to make it for twice as many people, I just double every element. Is that cool? Because then of course I'll make twice as much. But I don't want to make it for twice as many people. I want to make it for 2 more people. Ah, shit, so I can't just double everything. I could and have a ton left over.
Yeah.
Sure, that's probably what I would do. Because then I'm like, everybody
Which
liked
makes
it, I have
sense.
more. So this is 4 egg whites to 8 servings. How many servings do I want to have? 10. And I don't know how many egg whites that would lead to. Does this look familiar to anybody? This kind of idea?
8x
Oh.
times 40.
Yes.
Okay.
Love your notes.
Sorry. As a math teacher,
This is
I never get the reaction where I put a problem and somebody in the back goes, yeah. But that just happened. So
I'll do this
I
fun
just
one.
wanna,
Love your
I just
equations
wanna live in
stuff.
that moment.
The algebra's actually fun.
Let me make sure everybody really understands. If it takes 4 egg whites to make 8 servings, then would everybody agree that it takes 1 egg white to make 2 servings? So really all I'm saying is 4 to 8, what fraction does become over 10? Yes? Now there's 2 ways you can go forward. Can somebody tell me what next step you would take to try to solve this? What you got?
So 8x. That's 4.
Yeah, sure. So what's that called? Yeah, cross multiplying. We've done this before. We've done this shit before. This was to check to see if 2 fractions were equal. But aren't we told that they are equal? So therefore I can multiply this up and I know this is still going to be equal. And then what? Divide by 8.
Yeah, x equals 5.
So how many egg whites do I need?
5.
5. And I got 3. Damn it. So I go to the neighbor or whatever. Go to the store. It's Thanksgiving.
Nowadays you can buy egg whites in a carton.
Really?
Oh, that's true. That's true. Yes. 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 It's free. I'm not a big egg fan, but
Man-made wars.
my friends give me shit because I think eggs are glue. That's what their job. Eggs are food glue.
Yeah.
That's what they do. And when you eat eggs, you're eating glue. I don't get you. So I'm sorry. I just don't like eggs.
I
My
love
pork.
eggs.
Anyway.
Good scrambled egg.
So what we just created. Does somebody know what this is called when I set up an equation where 2 ratios are equal to each other? Starts with a P.
Probability. Percentage?
Problem.
Persnickety. Persimmon.
Performance.
A problem.
Proportion.
Problem.
It's a proportion.
I was close.
Okay, you guys all with me? You've heard that word before, right? Proportion. Proportion very often is used in place of percentage, but it's not really just that. It's this. It's setting 2 ratios equal to each other. Okay, this cross multiplication stuff, we've done it before in this class, and you guys have done it before outside of this class. Where else do you see ratios? Somebody think of another place in the universe you see ratios. Sure.
Casino.
In what terms?
Usually. Cards, payouts, that type of
Sure.
stuff.
So anytime you have odds of any kind, that's basically a ratio. Somebody else, anywhere else. So we got recipes, we got casinos, we got cats and dogs.
Gas.
Huh?
Gas.
Gas, sure. Wages, right? Aren't wages so much money per hour? That's a ratio. What about on a map?
Oh yeah.
We all carry maps in our pockets nowadays, which is neat. Beep, 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 Google Maps. All right.
My name is 3.4
When you
miles.
zoom in on the damn thing, doesn't it change the scale? So the scale could be 1 inch equals 2 miles, right? Then you zoom in, now 1 inch equals 1 mile, and zoom in, zoom in, zoom in, yes? You guys got it with me? And then you're still lost. Back in my day, we had MapQuest, so
Whoa.
then you were guaranteed to get
I
lost.
remember
And
that.
with MapQuest, I got actually lost in Yonkers, which was
Yeah,
great, so.
you have to like print it
My,
out.
It is.
my aunt got lost in Las Vegas.
I remember
Yes.
once when my grandma had me do that for her.
She's old and just like,
I was just about
look at your phone.
I love it how I start these little tangential conversations. Is everybody with this so far? Okay. Okay, not too bad, not too bad. Let me see, what have I done with all, there they are. I've got a little outline to keep me on track. Then you've got, for example, another thing that I was thinking about was scale on a map, miles per gallon in a car, that kind of thing. So let's say on a map, let's say we have a map and let me see if you guys freak out about something. Every half an inch on a map represents 5 miles in real life. 1/2 of an inch represents 5 miles. and I look at the map, and two towns are 3 inches, 3 inches apart. On the map. How far apart are they in real life? So what ratio can you set up from the beginning? You might not like it, but what is it? Yeah, 1/2 over 5. Now, one huge thing that hopefully makes nothing but sense, if you set up the ratio like that, oh crap, I love being next to the parking lot.
It's always something.
If you set up the ratio like that, what did you say the top is?
Half.
Oh yeah. Okay, sorry.
What if their class is like way over there? They're never
Yeah, I
gonna.
know. Why did people use an alarm anymore? Is anyone gonna go rush out right now?
No.
Okay.
Because it's what's funnier.
Not in a parking lot.
If an alarm goes off,
No.
nobody's saying, "Oh no, somebody's breaking into the car."
We're all just
Who
like,
is
shut the
shut off the alarm?
Guys, let's try this, okay? I'm gonna try not to rap because I'll show you why I teach and don't rap.
No, come on.
Do it, do it, do
That's
it,
the
do
lesson.
it,
Have
do
to
it,
stop
do it.
So if we set this up, we're saying the top is inches and the bottom is miles, correct? Okay.
Do you want to shut the doors?
We can try, shut the doors, yeah.
Okay.
Let me make sure this is set to a decent temperature.
Okay, that's
Better
oh,
already.
it's a lot.
Wow.
Oh, whoa.
Nice.
Wow.
Yeah, noise.
Noise canceling.
I kind of hear.
So we'll see
Oh,
if,
yeah, but
uh,
that's like
But
significant.
that's
hopefully
like
the AC kicks in. Supposedly,
It's loud.
it's better, but it's not. So we'll see what happens. Okay. That's a lot better, but it's still early.
Yeah.
So the top is distance on the map, and the bottom is distance in real life, correct? So how do I set up the other ratio? Where's the 3 go?
Bottom. Oh, no,
What did we
top.
say? Yeah,
Top.
exactly. So it's not a bad idea to put
Units.
units in there, but don't bring them with you on the map. Just so you know, that's inches, and then there's miles. Now, does anybody not like that there's a fracception going on, the fraction inside of a fraction? Because there's 2 ways to take care of that.
You could just do 0.5.
Sure, but it's still the same thing. But just to remind you guys, any fraction in the universe, I can multiply top and bottom of it by anything I want to except 0, correct? So if I double top and bottom of this,
It'll
What
be
happens?
2 10s.
It'll be 1
don't the 2's cancel? So I got 1 inch to 10 miles, like Armando said, I like it. And now you can just, I don't need the units really, they just get in the way. So you gotta be careful, the units help you put the numbers in the right place or else you get these really weird answers. And then of course we just attack it like we did a minute ago. And something really nice is gonna happen immediately. How do you do this? What do you do?
Cross multiply.
Yeah.
Oh, you also get the fun unit of inch miles.
Yeah. Yeah. 30 what?
Miles.
Miles, because it's in the mile spot. And it also makes sense that they are 30 miles apart, not 30 inches apart. Still is not big enough for the both of us. Okay. Sorry. This is just a joke for me.
Well, I mean, if you think about it, like they could share a border too, like how.
Yeah, I know.
how you think you do.
Exactly. But we normally think of like town centers
Yeah.
when we talk about Disney. Okay. I do have a worksheet, by the way. So today's not going to just be me talking forever. You're like, God Lord, it's almost as bad as a car. Okay, that's really all I have to say about ratios and proportions. They are cross multiplication stuff. Setting up ratios are pretty direct. At least one person is very excited about this. Okay, so I want to talk about percentages, and then I'll unleash you on this worksheet. So, what do you guys know about percentages? Give me anything about percentages that you know.
They're kind of fun.
I'm always curious about that. I like somebody's, like, I don't know what you want from me, just anything. They're kind of fun.
They could be of more than 100.
Sure. In certain situations, they could be more than 100.
You can have
Huh?
zeros.
You could have 0%? Is
Yeah.
that what you mean? Or,
You can have 0%.
sure, of course. And how could you represent a percent? You can represent it as a fraction. Can you represent it as a decimal?
Yes.
Yes. Does anyone know what the phrase percent means? The word is really a phrase.
%.
Percent.
Yeah.
How many cents in a dollar?
100.
100. So per 100. That's exactly what a percent means. It's per 100. So can anyone tell me 12%? How would you write that as a fraction?
12 over 100.
Yeah. So this is not true. The symbol for the percent sign has a history that does not involve this. But it's just kind of neat that the percent symbol looks like the number 100 and somebody just took it apart and put it back together. Do you guys see that? If I just took this and took these and put the 1 in the middle, hey,
What
it's
is
a
the
percent.
history of the percent symbol?
Huh?
What is the history of it?
I'm not going to go into that. Sorry. There's a history of the symbol X for algebra. There's a history of the square root
shit.
symbol.
Real?
Yeah, of course. It had to be come up with, right?
Yeah,
Anyway.
the history of them.
I'm still waiting to
It
take
was
that.
You'll
a
have to
whole-
wait till I make a history of math course, and then you can take it.
I will take
Honestly,
that. I would take that.
I would do that. I would. That'd
Okay.
be really cool.
I'm sorry, but you guys are in this class now. I'm sorry. So this will be 12 over 100. Is that cool?
Yeah.
So what is that as a decimal?
0.2. 1, 2.
Yeah, 0.12, because it's divided by 100. You move it back once for each 10. Does this make sense then? A percentage number will always be bigger than the decimal number. Because the percent symbol means to divide. I have not divided yet. So a percent number will always be bigger than the decimal number. Now who's got a shortcut to go from decimal to percent and vice versa? I just have to move the decimal 2 places. It's just dependent on which way do I go, yes? So here's a beautiful way to remember this. So for example, 0.07 would be what percent?
7.
7. So when I go from decimal, so if you write the letters D and B in alphabetical order, when I go from decimal to percent, I move the decimal that way.
Now you go. You do it.
When I go from percent to decimal, I move the decimal that way. Yes? No? I don't care if it doesn't make sense, just figure it out. But I always think this is a nice way to kind of remember. You can also remember that a percentage will always be the bigger number. So you got to move it over so this becomes bigger. So there's a lot of different ways you can kind of remember this. How we all doing out there? Some fractions you know already. You don't have to do any work. So for example, 1/4, 25%. Woohoo! 1/2. 1/2. 1/2 is 50%. Okay, I got worried. 3/4.
25.
75%. Yeah. Ba, 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 ba. Okay. So some you already know. Let's see. How do I go from? All right. Let's do a few more of these. What if I had 3/5? I don't want it to go to a percent, and I want to go to a decimal. You could go either way first, it doesn't really matter. So what do you want to convert that to?
So point.
Multiply by what now, sorry? Oh, yeah, okay, yeah. If I can make the bottom 100, that kicks ass. So real quick little side note. What's 11 over 100, what percent?
11.
Holy shit. What is 7.3 over 100, what percent?
73.
7.3%. Percent means per 100. So the bottom's 100, that kicks all the ass. Because then it's just the top percent, that's what it is. Percent means per 100. So what's wrong with this then? It doesn't have 100 on the bottom. How do I make the bottom 100?
Times 20.
Times 20. So I get
60%.
60 over 100, which is 60%, which is what decimal? Yeah, 0.60, which you can also write as 0.6. Kick ass. How we all doing out there? Okay, yes,
Is that a 73 or a 74?
I wish I knew.
On the right.
Over here?
No. The 7.3 right there. The one
you Yes.
just at.
Yeah,
Is that 7.3?
7.3, yeah.
Oh, okay.
I thought I made it better. I'm sorry. That's a good
The
three for
decimal
me.
I think the
point
decimal
more
part is a little
interesting.
point.
Yeah, make the decimal part darker.
Okay. Yeah, I'm sorry, guys. You have picked a teacher that can't write.
It's okay.
It's a good
None
one.
of us can write anyways.
Technically, we didn't pick you, you're the only one teaching us.
Ooh.
No, that's good. That's good. I walked right into that one.
Oh.
Thank you for taking the class. I know you have no option. The class has reached a cruising altitude.
Oh.
If nobody had done that, I would have been worried about everybody. Okay, what if I had, if I gave you, what about 1.29?
That's 129%.
Yeah, so to go to percent kicks ass. So when, I don't care what the decimal is. I move the decimal over twice. Right now, in this case, I've got to make the number bigger. So I'm at 29%. And then I got two ways I can write the fraction, and they're both equivalent. So what's percent mean again? Per 100. So the fraction could either be 129 per 100, or what's this mean? 1 and
29 over 100.
29 hundredths. And does everybody agree that those are the same fraction, yes? Okay, let me see. Those. I'm gonna give you the handout, if I can find it, here it is. Because here's a teachable moment, everybody's zoning out a little bit, so I'm just gonna stop talking to give you this. So what I want you to do is one side says percent group work, so I wanna focus on that first. Check.
Oh, we don't have the little guys this time?
Huh?
We don't have the little guys in the top?
No, Jeff barely remembered to print this out, so I didn't have the time to get the little guys in the corner.
Jeff likes the topic of person.
Yeah, you guys. So. If I leave group making up to everybody, many people just won't get into a group. So, let's do this. Let me see. 2, 4, 6, 8, 10, 12, 14, 15. Neat. So we can do 3. So you guys, right here. What's that?
It's like it's 15 divided by 3 is 5.
No way. Holy shit. You 3 are here is fine. You 3 are here. Is that cool? You 3 back there. And then you. Yeah. Just turn around. Turn around, bright.